Hello there, everybody. Here's your warm-up. Draw four coordinate planes and fill them in with the following. Good luck. A linear non-function, nonlinear non-function, linear non-function, nonlinear function, and a linear function. Okay. Going to want to pause the video, work on that because we're ready to go here. Alrighty, everybody. Can I get you back up here in 5, 4, 3, 2, 1. Let's see here. So I need four coordinate planes. And I think, let's see, what was the order I asked him for? It goes non, yes, no, yes, no, no, yes, 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 no, yes, no. So this is a nonlinear non-function. This is a yes, no linear non-function. And then this is a linear non-function. Oh, sorry, nonlinear function. Sorry. Let's see here. Nonlinear function. That's no linear function. Nonlinear function. And then we've got a linear function. All right, let's see here. Can I get a little bit of help? And that is going to come from, oh, here we go. Let's see here. Jane, what's your favorite color? Blue. Will you draw for me a nonlinear non-function on that coordinate plane on the upper left? Awesome. Do you guys agree? Is that a nonlinear non-function? Yeah. Beautiful. I can't connect at all with a line, and what am I saying here? And it's a non-function because it fails the vertical line test. That there's inputs that have multiple outputs. Eliana, what's your favorite color? Teal. So I'm going to pull out the line tool to help you out here. Can you please draw a linear non-function? I know you're a little limited on that. Awesome. A linear non-function would be a vertical line. It's the only way to make that happen because that's the only way you can have it so that one input has multiple outputs. So that would be like x equals something. Okay, perfect. How many of us are able to get something like that? Perfect. Sam, what's your favorite color? All right. Will you please draw a nonlinear function on this third one here? Nonlinear function right there. What do you got for us? Awesome. How many of us agree that that's a nonlinear function right there? Perfect. Very good. All right. And then finally, let's get that linear function on there from, let's see here. That is going to be, let's see here. Addie, what's your favorite color? Purple. Will you draw a linear function in that last one? Beautiful. How many of us got four things like this and feel comfortable with when things are linear and functions and all that? Love it. All right, guys, it is the 80th day of school. Did you guys know that 80 is the sum of the first four twin prime pairs? So twin primes are primes that are two apart. So like 3 and 5 are a twin prime. And 3 plus 5 is 8. 5 and 7 are a twin prime, and 5 plus 7 is 12. Then is it 11 and 13? 13, which is 24. And then it's 17 and 19, which is 36. And if you add all these together, you get 80. Yeah, go ahead, Shrion. No, because they are a special situation. Twin primes are two apart. Like, because if twin primes were only one apart, there'd only be one pair, and then that would be boring, right? I forgot to write down what day it is, and it might interest you to know that today is National, I should write it down, National Chocolate Covered Anything Day. Yeah. Chocolate Covered Anything Day. And then that is 12 point, is it the 16th today? 0.24. Okay, perfect. Hey, yes, go ahead, Eddie. That's perfect. Chocolate covered popcorn. Hey, chocolate covered blank. I'm gonna take 5. Who has something that's a chocolate covered blank that is delicious? Chocolate covered popcorn. It has been taken. Justin.
Chocolate covered strawberries.
Chocolate covered strawberries. Absolutely. Iris. Wait, chocolate covered what? Oh, excuse me. Very different. Shrihan. Yes, absolutely. Arden. Chocolate covered elephant. Never tried it, but I'm assuming it's great. Go ahead. Chocolate covered grapes. I've never had one of those. Well, indeed. And then Ellie. Chocolate covered Oreos. I mean, why not just double down on the chocolate? We got one more. Go ahead, Ellie. Chocolate covered marshmallows. You know, I understand that chocolate covered ants are a thing, and are actually not bad. Are actually not bad. Okay. I mean, if you're gonna eat ants, you might as well put some chocolate on them. All right. Anyway, got a pencil. Today's topic is that table linear? Is that table linear? Oh, oh, you're right. Oh, I forgot to do that. Thank you. Can I get you in 5, 4, 3, 2, 1? You guys are absolutely right. I forgot to do the essential questions. Where are my manners? Evan, what's our first essential question today? Yeah, how can I tell whether a table represents a linear slash nonlinear function slash non-function? Hey, before I do the Jeopardy for today, did anybody get that last one from Friday? Where it was after working with the guitarist and collaborating with with the band on the song "The Alcott." Many Swifties found themselves at this self-described sad dad band's shows. Did anyone know which sad dad band that was? Yeah, that was a tricky one. The correct answer was the National. The National. Yes, Addie. Really? Did you guys do graphs or tables on Friday? Was it graphs and tables with you guys? Okay, well, we'll do that. That's fine, because maybe that'll just give us some extra time to practice, which I'm cool with. This week, it's the holiday movies through the MPAA. The MPAA is the rating system, so we'll just go through from G to R on the MPAA rating systems. So Gonzo stands in for Charles Dickens in this classic tale retold in 1992, rated G. That is indeed a Muppet Christmas Carol, which, two things, I believe is the best Christmas movie, and also I believe is the best rendition of A Christmas Carol, and that includes the book, A Christmas Carol by Charles Dickens. I really believe that A Muppet Christmas Carol is better in every way than the book, for once. And if you disagree with me, that is totally fine. You're entitled to your opinion, as I am. Go ahead.
So yesterday we watched the Muppet Christmas Carol, and the first time I ever watched it was last year, and just rewatching it, I'm like, oh my gosh, I love this movie.
It's so good.
So funny, it's so goofy, it's so wholesome.
It's so good. Yes, Carol. Because I was saying Muppet Christmas Carol. Absolutely. And Carol's like, why is everyone talking about me? And then traditional holiday foods, we're looking for turkey. We're looking for turkey. Perfect. All right. Anyway, there we go. So if you guys already did a little bit on what makes a table linear or nonlinear, a function or a non-function, let's take a look at some examples just to make sure we're feeling totally good about that. So let's make a table XY. Because the self-assessment should have just been the graphs. That means that if we just do this really quickly, we can give you some time to work on your self-assessment today. And the x's are going to be -2, -1, 0, 1, 2. And the y's are going to be 5, 2, 0, -2, -5. You did that one exactly? Okay, let's see here. Never mind. How about this one? X and Y. Did you do? Okay, I got this. I'll grab this one instead then. How about this one? Negative 4, 0, 4, 8, 12, 16. Did you guys do this one? Good. Okay, I got some new ones. That's okay. I didn't realize that that video had both of them on there. That worked. That's good. That's okay. And then Y is going to be negative 10, negative 7, negative 4, Gesundheit, negative 1, 3, and 6. So when I say teach, I want you to say, okay, is that linear or nonlinear? A function or a non-function? And how do you know? Teach, teach. Hi. Yep, that's fine. It's right up there. Oh, that's perfect. Yeah, great. Okay, let's see here. Can I get you guys back up here in 5, 4, 3, 2, 1? All right. Justin, is this a linear function, a nonlinear function, a linear non-function, or a nonlinear non-function?
I didn't really finish, but I think it's non-linear function.
Okay, so let's check to make sure it's a function. If it's a function, then we shouldn't have any repeated inputs with different outputs. And as you can see, we don't have any repeated inputs at all, so we know we're okay. That if this acts like a function everywhere, we've defined it. To check if it's linear, we're going to check to see if my change in y over my change in x is always the same number. So if this is my change in y and this is my change in x, looks like that's an increase of 3, increase of 3, increase of 3, increase of 4, increase of 3. Now, guys, is this necessarily bad news? No, it might be linear even though I have a different change of y. As long as this works out over here. This is an increase of 4, increase of 4, increase of 4, increase of 4, increase of 4. So is this linear or nonlinear? This is nonlinear because the change in y over change in x fraction here is 3/4, 3/4, 3/4, 4/4, which is 1,
So
and
in order for it to
3/4.
be non-linear, it has to like be like it's not the same thing over and over.
That's right. It has to
Okay.
have the same change in y over change in x every time. If the change in y over change in x is ever different, we know it's not linear because it has to have the same every time. How many of us either got that or see how we got that and aren't too alarmed? Oh, that works. Perfect. Okay, let's see here, guys. How about this one? X and y. The x's are -2, 0, 4, 8, 20, and 24. And the y's are 7, 5, 3, 1, -5, -7. Go ahead, guys, give that a try and let's see how that goes. Teach! Yes. Oh, yes, that's going to be, he's table, period 3, table H. Period 3, table H. Okay. Can I get you guys in five, four, three, two, one? What do you guys think? Is this linear or non-linear? A function or a non-function? Let's see here. Carol, is that linear or non-linear? And is it a function or non-function? And how did you know it was non-linear? Ah, sorry, I see what you mean. That was an increase of 2, an increase of 4, an increase of 4, increase of 12, increase of 4. Now, is that by itself a bad thing, Carol? Oh, she's like, maybe? Well, here's the thing. It's okay to have this kind of wild changes and we're changing x and change in y. What's bad is when your change in y over change in x fraction are different. We'll take a look at that in just a minute. What about, so this one was 7 to 5. What was the change there? Okay. And then, yeah. Oh, you're right. That's a decrease in 6, and that's a decrease in 2. So negative 2 over 2 is negative 1. Negative 2 over 4 is negative 1 half. You can actually stop right there. If I'm asking if that's linear or nonlinear, as soon as you get a different change in y over change in x, you know that it's not going to be linear. Yes, Grace?
So I noticed something on the So basically, the thing is like 4 over the 2 for majority of these.
Uh-huh.
For 12, it's for the one that's plus 12 and minus 6. It would actually be the equivalent of 4 over 2. Like I mean,
Yeah.
fraction wise, because 6 times 2, well, negative 6 times negative 6. Negative 2 times negative 2 would equal 4.
Yeah, perfect. Very good. All right, let's take a look, guys. I've got another one. This time we're gonna play it a little bit like a game. Is that table linear? So let's give an x, y over here. I'm actually gonna do a horizontal table, and it's gonna go like this. You're gonna give me the x's, I'm gonna give you the y's, and you're gonna decide if this relationship is or is not linear. All right, let's see here. I'm ready to go. Carol, what? Give me a number. Any number. 7. If the input is 7, the output is 4.5. Let's see here. That's going to be Holland. Give me a number. 9. 3.5. All right. Let's see here. Avi, give me a negative number. Negative 21. Negative 21. 18.5. And I'm going to get one more number. Any old number you like. And that's going to come from Joey. 2. 7. What's your instinct telling you guys? Do you suppose, a function or a non-function? What do you guys think? Okay. Or sorry, linear or non-linear? Excuse me. Okay, let's find out, guys. Check. Is the change in y over change in x fraction the same every time? Teach. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Let's see here. Let's go for Hoibing. Do you think this is linear or non-linear? It's linear? How many of us think that it is linear? Okay, let's check. How did you find that out, Hoibing? How did you know that? What, you guessed? Okay, so let's see here. In order to check if it's linear, we're going to check the change in y over the change in x fraction for every step of the way, okay? From 4.5 to 3.5, how much did it change, Hoibing? Up or down? It went down one. How about 3.5 to 18.5? It went up 15. And about 18.5 to 7? Down, I think 11.5, yes? Is that right? Perfect. And then we're going to check the change in x. That was my change in y. That was my change in x. 7 to 9, how much does that change? 2, an increase of 2. 9 to negative 21, a decrease of 30, yeah. And then how about negative 21 to 2? An increase of 23. So now we're going to check if the change in y over change in x fraction is the same every time. That would be negative 1 over 2. That's negative a half. That would be 15 over negative 30. Does that reduce to negative a half? Yes. And then negative 11.5 over 23. If you pop that into your calculator, guys, you'll see it's negative 0.5, which is negative 1 half. So since the change in y over change in x fraction was always the same number, that has to be linear. How many of us were able to get that as linear or see how we got that in our 2 alarm? You guys doing okay? Beautiful. One more thing I want to talk to you guys about. Here we go. Oh, this is mean. Okay, here we go. Got a pencil? X and Y. Here come your X's. 0, 2, 3, blank, 15, 21. Here come your Y's. 7, blank. Wait a minute. Oh, no, excuse me, not 7. That's not. 0 is 1, excuse me. 1, blank, 25, 81, 121, blank. Now here's what I'm going to do, guys. I'm going to tell you that this relationship is linear. So I want you to not only tell me what the change in y over change in x fraction is going to be, I want you to use the fact that this is linear to fill in the 3 blanks I've given you to make sure that this really is linear. Give it a try, guys, and teach. Yes, calculators will definitely help. Okay.
It's 0.08.06666667 for most of it.
Okay. Can I get you back up here in 5, 4, 3, 2, 1? Okay. So guys, here's the thing. If you get stuck on something like this, when I tell you this is linear and it's got blanks, one of the problems is when you try to set up your table caterpillar, we kind of fall apart, right? Like I don't know how much one goes up or down to get to this next one, but I do know that, and I don't know how much it goes up or down to get to 25. So what we're going to do is we're just going to make the legs follow what we do know. 1 to 25 is an increase of 24. 0 to 3 is an increase of 3. Then the next one I know is this one. 25 to 121 is 90. Is it 96? Is that 96? And 3 to 15 is Gesundheit, is an increase of 12. So if we do 24 divided by 3, I get 8, excuse me. And if I do 96 divided by 12, I also get 8. Right? I also get 8. Which means that's my change in y over change in x fraction. So how do we turn this into the blanks? Well, if this is an increase of 2, that has to be an increase of what to make it so that when I divide them, I get 8. What divided by 2 gives me 8? So that has to be an increase of 16, which means that is 17. Guys, this 25 to 81, 25 to 81 is 54, no, 56? Is that an increase of 56? So now we have to ask, 56 divided by what is going to give me, 56 divided by what is going to give me 8? Is it 7? So that must be an increase of 7. And 3 plus 7 is 10. 15 to 21 is an increase of 6. What divided by 6 is going to give me 8? Is it 48? So that must be an increase of 48, which is 169. After seeing that once, how many of us are feeling okay about those? Very good. Awesome. Very good. Let's see here. Okay. We have time for one more, guys. Can I get you in 5, 4, 3, 2, 1? Okay. We're going to do that guess a number again, and we're going to see if we think that it's going to be linear or non-linear. So let's see here. Shreyan, give me a number. 57 goes in. 3,192 comes out. Okay. Let's see here. Can I get a little help? This one's going to come from Iris. Give me a number. 7 goes in. 42 comes out. So right now, guys, do we have enough information to know if this is linear or non-linear? I would actually say no, because imagine these 2 points on a coordinate plane. 57, 3,192 and 7, 42. Could I connect them with a line? Sure. So there is a line that does connect both of these. What you got for me, Asher? You have a question for me? Oh, I'm gonna draw cards for that. I'm gonna draw cards for that. Let's see here. LAR, give me a number. 32 and then 992. Can somebody give me a negative number? Let's see, Bradley, can you give me a negative number? Oops. -5 and 20. Blackbirds baked in a pie. All right, guys. Is that linear? Yes or no? And how can you tell? Teach!
Yeah, I know, I know.
Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Praksha, do you think that is linear or nonlinear? It is nonlinear. That is true. This is a decrease of, goodness gracious, 3,150. And this is a decrease of 50. And if you divide those, negative 3,150 divided by negative 50, what is that? Does anyone have that? What is it, 53? 63. And then this was an increase in 950. And this was an increase in 25. Is that right? And then 950 divided by 25. Did somebody have that one for me? Yeah, Avi. 38. And we can actually stop right there. If ever you get a different change in y over change in x fraction, you know it's nonlinear. So that's nonlinear right there. But it is a function, certainly. And in case you're curious, the function was x times x minus 1, excuse me. That's what it was, in case you're curious. In case you're curious. That's all I've got for you guys. If you'll put your calculators away, head back to your assigned seats. You do have a self-assessment. It's not up yet. I haven't had a chance to publish it, but I will do that later this afternoon, okay? So be on the lookout for that.